Hi everyone, welcome SAS Programming in 90 days. Welcome in day 39 session. So we continue with the SAS VIYA. In the last session, we have done the linear regression in econometrics. So now we are going more deep in the econometrics and we will see the logistic regression. Okay, so first of all, what is a logistic regression? So in the SAS VIYA, when you see they will be showing as a logit model. Okay, so logit model is a logistic model, is a full name, is the also called as a logit model. It is used to predict the result of a categorical dependent variable based on one or more continuous or categorical independent variables. In the other words, it is multiply the regression analysis but with the dependent variable as a category. So logistic model is used to model the probability to certain class or the event that exist, such as a pass fail, win loss, that kind of data we have, alive or dead, healthy or sick, this kind of data, that is a categorical, that is a text is available, then we are using the logistic regression. If yes or no is available in my data, okay, my dependent variable is available like this, so we are using the logistic regression there. This can be extended to model a several classes of events, such as determining with the image contains the animals, let's suppose cat, dog, lion, etc. So this is used for the fraud detection. So in the fraud detection we are using the logistic regression, and diseases diagnosis, in also we are using the logistic regression. Spam mail, if, let's suppose there is a spam mail are there, so that is a categorical one, so we can easily do with the logistic regression. So linear regression versus logistic regression. So where we are using the linear regression, where we are using the logistic regression. So linear and the logistic regressions are the two famous machine learning algorithms which come under the supervised learning, because we have the label data here. So this will become into the supervised learning techniques. Since both the algorithms are of supervised in nature, hence these algorithms use a label data set to make the predictions. So with the in the econometrics, what we are doing some predictions, but the main difference between them is how they being used. The linear regression is used to solve the regression problems, where the logistic regression is used solving the classification problems. These descriptions of both algorithms is given along with the difference tables. So now you can see here we have the two chart here. So first in this they're showing the linear regressions, in the second they're showing the logistic regression. In the linear regression, now you can see here this graph is going my graph is going like straight line. We have this straight line like this. But if you see the logistic regression is like doing like is this is a curve, it's like doing going up like this. So you can take this is also the difference, and the another difference is we have the linear regression as a number, and the logistic regression is like the characters or text. So this is the logistic regression. So what is a logistic regression? Logistic regression is one of the most popular machine learning algorithms that come under the supervised learning technique. It can be used classification as well as for regression problem, but mainly used for classification problem. Logistic regression is used to predict the categorical dependent variables with the help of the independent variable. The output of the logistic regression problem can be only between 0 and the 1 only. Logistic regression can be used where the probabilities between two classes is required, such as if you can say yes or no. My answer is yes and no. So there is a two category variables, as whether it is rain today or not. We have two category variables, rain today or not. Okay, either 0 and 1 or either true and false, we can say. So let's see how we are creating the logistic regression model in the SAS VIYA. So we are using the SAS task in the econometrics. So I'm going into the SAS studio. This is my SAS studio. I click on the SAS develop a SAS code. So in the SAS studio, we are the econometrics. In the econometrics, the logistic regression is available in the cross-sectional data model. So I click on the cross-sectional data model. Now this is cross-sectional data model is open. Now first of all, like the linear regression, we have to select the first of all dependent variable. This is a mandatory one. So dependent variable is required. So let's suppose I given the dependent variable as the age, and the continuous variable I given here the height and the weight, and the categorical variable. So you need to define the category variable. So category variable I given the gender, because that is only we have the male and the female here. So this is category variable, this is the mandatory one, so that I given. Now in the model you can see here we have the linear regression. In the last session we have done, then we have the logistic regression. So I start with the logit. Okay, now you can see here automatically they write it the proc QLIM, and my data is this, and the model is created. Age is equal to height, then weight, then gender, then we have the distribution as logistic. Okay, now you can see here this is distribution as logistic. They are showing distribution as a logistic, and the limit one is 0. Now let's run this code. Now you can see here this is the output we have. We have the discrete response. Let me maximize it. Now you can see here we have the discrete response of profile of age. Now you can see here we have the age frequency here on 11 age. The student in the class, we have the 11 age is 2, 12 age is 5, 13 age is 3, 14 age is 4, 15 age is 4, 16 age is 1. Okay, then we have the classification, the class level information we have. We have class level information, we have the gender wise, two levels we have, female and male, F and the M. Then we have the modal fit summary here. In this summary, the number of variables they are showing. Okay, number of observations 19, log likelihood we have minus 19.3600, maximum absolute gradient, number of iterations they given the, okay, the all the information about my model they given. Now you can see here this is the predicted age by the regressor. So in the prediction, now you can see here we have the age. Let's suppose if a student age is 12, then my graph is maximum is going to 60, not below 260. But if my age is 13, my line is going above to 60. Okay, not the 65, but now my graph is a categorical one. Now they going like the curve. Okay, it's not going straight line or the horizontal or vertical line, it's going the curve something. So now you can see here it's not going to 65. Now you can easily identify if 14 is age, then maximum below 70 we have the age, 70 weight we have, height we have, and if my 15 age, then my height will be 70. Now you can also see the weight. If my weight is 12, then maximum weight is 80. Then this is the weight is going 113. Okay, so this is a curved line, so we can easily analyze what we are looking for, how my weight and the how is easy to predict the future also, because if now we can easily understand if my weight or my height is depend on the age. If my age will be increased, my height and weight also increase, correct? So in the below we have for the gender wise. Okay, in the gender wise we have, now you can see here, this is the logistic regression. In the logistic regression, between variable between 0 to 1, correct? Lower is a 0 and a maximum is 1. We have only 0 and the 1. Now you can see here in the female, this is related to gender F. Okay, now 13 and the age. Okay, so this is the now you can see here logistic regression also here in this gender wise predictions. So this is all about the logistic regression, how we are creating, how we are selecting. Now you can also see here we have in the model selection also we have the option of the this analyze the. Okay, now you can you have to select the variable on the variance. Minimum variable is 1. So let's suppose I'm selecting as a name. Sorry, I selected the height here in the analysis. Now you can see here we have the analysis according to the height also here. We have the height variable, they will be show the analysis also here. So this is how we will see the logistic regression, how we will create the logistic regression. We have the more plots related also here. So if we are looking for the options, okay, in the options we have default plot, selected plot. If you are looking for the selected plots only, so individual plots also we have, so we can select it. And the method we have the many methods, same like the in the linear regression we have. Okay, so I selected the both options. Okay, so predicted value of regression you are looking for, or the, so we have output options, we have many output option. Okay, let's suppose I selected linear predictor, the predicted probabilities, everything is selected. Okay, so you can also control your output with these options. Let's see the output in the main window. Now you can see here I selected the all the plots in this. Now you can see here this is a predicted age by regression. Then we have predicted age by regression of according to the weight. Then we have the according to the gender. Then we have the linear predictor I also selected, so now they going the linear. Now you can see here the linear we have the straight vertical line. This is not the curve. Now this is also the linear predictor. Then we have the same is a linear one. Now this is a logistic because this is the curve one. So now this is showing the response probability of age by regression. Okay, now you can see here this is going 0 to 1 maximum. So we have only one variable 0 to 1 in the logistic regression that is showing. Okay, so this is also the curve here. This is also the according to that one. Now you can see here this is the related to the age one. in the age they categorized into the 1 2 3 4 5 6. In the above they given the here. Now you can see here, this is the index 1 2 3 4 5 6. Now they will be total frequency same with 4 frequency they created here. Okay, for frequency the first line is going here to here. Okay, second line all the curve probability they given about the logistic regression, the maximum 0 to 1 they are going. This is the predicted probabilities of the age by regression. This is the predicted probabilities of age by regression. Okay, this is by the height, this is by weight, this is by the gender. Okay, so all the analysis we selected, that's the reason it's showing the all the plots here. So I selected this all the plots, so you can control the output, you can control the plots that you want. Also you can save the output if you want in the work. Okay, predicted values if you looking for, so you can save the only the predicted values, and you can use the predicted that values in your visualization, or you can create a dashboard with that one. Okay, you can save these in the work and you can use this. This is the information what we have done on this cross-sectional data model. We analyze a cross-sectional data model. Folder is Econometrics, autorec, qlim, proc we uses countrec, and this is the resources they given. If you want to study, you can study it. So this is all about the logistic regression, how we are using the logistic regression, how we are creating the logistic regression. This is the all code what we have done on the logistic regression. Thank you guys.